Okay. So. So last week we had the we had the quiz 1. So let me go through that really quick. Let's see if I put it here. So quiz 1. So the first question is to identify whether or not it's a primary or secondary data. And if it's a primary data, how are we going to collect it? Through observation, experiment, or survey? If it's secondary data, usually we just buy it, okay? So the first one, Apple would like to measure satisfaction level of the customer who purchased the new iPad product. So it will be primary, right? And then the satisfaction, it will be, through survey. And then the second one, Pepsi want to determine whether or not the consumer prefer certain tests, the test of Diet Pepsi or Diet Coke. So there will be experiment that the customer do the test, the blind test, and then ask them what they like the most, okay? And then you know which one they pick. And then C, each Charlesburg University needs to determine the current inflation rate to determine the annual salary increase for its staff for the upcoming year. So the inflation, we have the inflation data last week. So that's the secondary. And then McDonald's want to determine the average weight. So like I think I kind of talk about it. So if you use survey or experiment, it doesn't like really work. So you have to observe how long they wait in a normal setting. So that's it. And then second question, identify the type of data, qualitative or quantitative, and then what kind of data. So we have nominal, ordinal, interval, and ratio, right? So IQ is not ratio, so it's a lower level of interval. And then the price for gas is ratio, because you can say $2 is like 2 times expensive than $1. And then the data grade, it's ordinal. It has different, the order means different things. And then the number of boxes of the frosted flakes, there will be, it's an integer, but it's still ratio, okay? So it's a ratio. Some people put an interval, but because we can say 0 box, and the 0 means 0. And then the last one, the types of car driven by students in your class. So that will be nominal, okay? So the 3A that everybody get this right. So this one is, you can see like they have the same year. So this is the cross-sectional data. And then this one, it's the same team and same team but different years. So this is the time series data. So the last one, identify, whether or not it's descriptive or inferential. So descriptive is to describe the data, right? So A, the households with children under age of 18 are more likely to have access to internet than family household with no children. So the more likely kind of, try to indicate or estimate some kind of direction. So this is inferential. And then B, Julie, who cuts and styles hair in her home salon, had 23 customers last week. So this is just some information about this thing. So it's description, right? So it's descriptive statistic. And then C, the average exam score for the statistics exam was 88. So this is also a descriptive because it just kind of describes the average. But if I say the average of the statistic exam was 88. So that means the class in this statistics class, the student in this statistics class, they don't study. And then that's inferential. Okay. So D, a recent poll showed that 57% of Americans had a favorable opinion of the President of the United States. Okay, so 50% favor this. So this is inferential. Okay, so that, but whether or not, yeah, so the poll shows that they actually favor this president. So that's it. Okay, so this is chapter 1. So next, let's move on to chapter 2. So we are going to talk about what exactly, like we know approximately what is descriptive statistics, but what kind of method we can use to show the descriptive statistics. Okay. So the purpose of the descriptive statistics is to display the data, to tell us, the information of this data. Okay. So this chapter, we are going to show you what are the methods that we can use to explore the data we have. And we can kind of group them into tables or graphs, so to be easier to understand the characteristic of certain data. So for example, I went to McDonald's to record the waiting time to be served on the drive-through. 2 minutes, 2 minutes, 9 minutes, 0 minutes, 8, 9, 10. Okay, so when we see this, does it tell you anything? It's just, you probably would like, oh, what is that? And then, okay, that's it. So we need to kind of organize this data. Okay. So how do we do that? One thing we can use this line. We can use the line to kind of record the frequency. How each number show. Like if we go back, you see that 0 shows 1, 2, 3, 4, 4 times. Okay, so there are 4 customers out of, I think this is 50 customer. They don't need to wait. They wait less than 1 minute. Okay, so we can put it into the line. So this is a line chart, and then it will show us, oh, and then the majority of the people wait for 8 hours, 8 minutes. Okay, so that's the frequency. And so sometimes we can use the chart, okay, to show people that get your attention. Because if you compare this with this would be more like, it would draw your attention better than this one, right? This one's like so messy. So we want to see this one. Okay, so sometimes people like the tables or charts. And some programs, they will use different, like the one we are using is Excel. I think we also have SPSS, but we are, and then stats. If you are in the business analytic minor, you will learn how to use stats. But here in this class, we will use Excel. So you can use that to put in some chart. Okay. And we already talked about this. So for the quantitative data, usually they have numerical values as numbers. For the qualitative, we might need to use some, different categories. And for the qualitative data, we will use different charts. So one thing that's used a lot is the frequency distribution. So it will show how many times certain data show up. Okay. So like the waiting time example, we use the chart to show the frequency distribution, like the one I show you. And you can also use table and a chart to describe data. So like here, this is the same from the same data we saw, like from the second slide. So we have the wait time from 0 to 10 minutes. and then how many. So total we have 50 observations. So this is the frequency table. Or we can use relative frequency that shows the portion of the total number of the observation, and then compare that to specific value, like 0, 1, 2, 3 minutes. Okay, so like here, what we do is we use 4 divided by 50, we'll get 8.08%. And 1 divided by 50 is 0.02%. And so on and so forth. When you add it up, it should be equal to 100%. So that's the relative frequency. And then the cumulative frequency, you basically add up different relative frequency, and then in the end you get 1. Okay. So basically we have the relative frequency here, 0.8. So the first category is 0.08, and then add 0.02 with 1.1, and 0.1 add 0.08, 0.18, so on and so forth. So till the end will be equal to 1. Okay, if it's not equal to 1, there's some mistake somewhere. Okay, so this is the frequency, and when we use Excel, when this is a number, we can easily use Excel to do the frequency table. Okay, I'm going to just show you how to do this. We have a file after E2L. So under the class, A, and then under content, we have chapter 2. So just use the Diamondback's data, download it, and this give you the data, the raw data. Okay, so this one has also 50 data, right? So what we can do is, with the frequency table, you can put it here. You can say equal to frequency, and then when you click, double click, you see the data array and then the bins array. So this is the data. Okay. Oops. And then comma, and I can select the bins here. I should put in some numbers, but I didn't. So wait. Let me put in 0, 1, 2, 3, 4. Yeah. Oh, is it only? Oh no, 5. Do it again. And then enter. Here. Oh, wait, that's weird. But last time when I did it, it would automatically calculate everything. What's going on? Oh, wait, let me try this again. So let me move this, let me move this down. And because I don't have a, yeah, and then I should do the like this. So okay. Equal frequency. Select the whole area here, and then select here. In theory, it should show. That's so weird. that yesterday when I did it, it shows the whole thing here. You don't need to follow this, I just want to see that big line. So it should be, this is wrong. What's going on? So weird. Would you guys try your Excel, see if it works? Because I tried on my other computer, it actually worked. Why? Doesn't work? Oh, wait. Yeah. I don't know why it's good. Try this. No. Here. What? Sorry. I don't know what happened. It worked before. Okay, hit Control Shift Enter. I didn't need to hit that. Control Shift Enter. Control Shift. Oh, now it worked. So Control Shift Enter. It should work. Any question?
No, I was gonna say, if you go to the formula tab at the top and then go to insert function inside the frequency from the left, insert function on the top of it. Then inside the frequency, oh, it's already up there, but that's how you do it manually.
Yeah, and then then you don't have to click.
Yeah,
You don't have to do Control Shift Enter. Yeah, but yesterday I didn't need to do it, just automatically show up. Yeah. So this one like help us to calculate, to kind of organize this data for us under Excel. This is the numerical data. Okay, when we have qualitative data, okay, I'll show you what to do next. Okay, so this is how we get frequency. And to get histogram, you can select this. Okay, just follow this. You can do data analysis.
More so like, that's what practice was about. It was about practicing the script. Like, this is what goes on and this is what we have to do in order to, and this referee is gonna miss this call. Because they
I can hear you now, but it's like your voice sounds very different.
Good, different or bad?
Now it's good. Now it's good.
Okay, yeah, it's because of the I think it's the internet or something.
Okay.
Weird. I'll use this. Oh, this should be, yeah, this should be the one. So this is the chart we want by using this different beam. Okay, histogram. And so this is just one way to show, like it tells you the frequency of different numbers showing up. Okay, so this we separate into different categories. And then we have, this is the histogram chart. So it should be like this because it's separated into different frequency. And then we have different type of histogram chart. So when it's a continuous information, then it's connected. Okay, but if it's different categories, then it's separate, like the one you saw under different beam. Right. So because of that, we actually have two different type of data. One is called discrete data, and the discrete data usually you can count it as an integer, as whole numbers. And then we have continuous data. So, sometimes they have the decimal points. Okay. So for the example we had, because we put it in different bins, so it's like for 0, this is the one category, and then 1, 2, 3. So there's nothing between. There's no like 0.5. So this is the average heat for different layers for from Diamondbacks. So this is that, and then they have the frequency table. So you see here, there's nothing like 0 and 1 is not connected. Okay, but if you see here, it's connected because we have, for example, the different classes, the grade they get. Okay, so some people they'll get maybe 88.5. So that has a decimal point. So this is like, in different, so it's connected. But if we separate them into A, B, C, D, then it become, they're all category. Okay, because there's nothing like, oh, we do have A minus, but we will group them in. If we group them into A, B, C, D, then it's different than the GPA. The GPA will be connected. A, B, C, D will be discrete data. Okay, discrete. So there are two types of data. So when we have quantitative data, we want to think of the total number of observations. Okay, so and then we want to group them into different classes. Okay, so how do we do that is like the example we have the observation of 50. So we have we have observation, the sample size is 50. And 2 to the power of what? 6? Is it 6? Yeah, 2 to the power of 6 is 64. So that, and then the one before 2 to the power of 5 is 32. So we want to categorize those into 6 classes, 6 categories. Okay, so that's how we usually use it. And then we use the 6 and then find the largest number minus the smallest number. Then there will be the range, the width of different classes. So the example here is this. So this one is when you call Dell customer support, how long you have to wait on the phone. Okay, how long you have to hold. So it range from 0.6, I would say hours, but let's say 0.6 minutes to the longest is 7.4 minutes. Okay, so how do we, like, how many data are here? 10, so 50, right? So based on this, how many kilovolts we need to put it into? 5 to 2 to the power of 5 is 32. Is 32 greater than 50? So we'll go to the next one, which is 6. So we need to group this into 6. And what we do is we can use 17.4 minus 0.6. That's 16.8. 16.8 divided by 6. That will be what? 16.8. What? 16.8 divided by 6, 2.8. Okay, so each the width will be 2.8. So that means we can put it like from 0 to 3, 3 to 6, 6 to 9, 9 to 12. They put it, we can kind of round it, or if we want to use 2.8, that's okay. Then we will use like 0.4 to 3.2, something like that. But to make it easier, we'll use 0.3, 3.6, then 0 to 3, 3 to 6, and then 15 to 18. So we have 6 different categories. So by using that, we can calculate the frequency, the relative frequency, and then the cumulative frequency. Okay, so this can kind of give us a better description of this data compared to this one, right? So you see from here, the most common waiting time will be between 3 to 6 minutes. Okay, by Dell, which is not true. I don't know how many of you call Dell. I waited one hour, sometimes more than 1 hour before. Yeah. So when we have too wide of the class, like in the previous example, if we say 0 to 10 and then 11 to 20, we only have 2 categories, and then it doesn't really tell us much. Okay, so when we're too wide, then we have a small number of classes. Then we might ignore the important patterns because everything will be in between these 2 categories. But if we narrow the wide classes, the narrow, classes, it will give us larger number of classes. Like if we do 0 to 1, 1 to 2, 2 to 3, then it will give us 17 different classes. So some category, they might have 0 in them. Okay, so that's why this is like something to help us to understand the data, to summarize the data. Okay, by doing that. And then for the qualitative data, like gender, location, okay, like the nominal, the ordinal data, we can also use Excel to help us. But instead of using the frequency table, we have to put in what is that? The formula called count it. Okay, so let me see if we have, let me see what data. Golf club, oh, I can do this one. So let's download golf club. And then I can do, so let's see, wow, so there's 100, right? So we have tailor-made. Tailor-made. Okay. Nike. Anything, any other brand? Oh, okay, only 3 brand. So what we can do is we can use counted. Count, means we are going to count this if something happens. So here is the range. So we want to count here, right? So this whole thing is the range. And then the criteria will be the front here. We want to count this. Whatever it shows this, tailor-made, then we want to count it and see how many are there. But before we add this, I need to put a $sign here. You don't need to know why now. So, but if you take 325 out, it's only 1. So all I need to do is to drag this down and it will calculate. So if I do sum, it should be adding up to 100. Oops. I forgot to put this. So when I do this, it should be 100. So that means we add everything here, okay? So this is the frequency for the qualitative data. And we can do count if, and then you put this name here. And the reason we need to put $sign is when I drag this down, if you see, this goes down when you drag the formula down on Excel. It automatically moves to E3. If you go up here, it's E2, it's this one. So if I don't put $sign here, this whole thing will also go down 1. But if I put a $sign there, it will stay here. Okay, let me just show you. You take out the $sign. Okay. You just take out the $. Oops. You take out the $sign. So if I do this, break it down, still the same because the first 3, okay, the reason for that is because the first 3 happen to be different brand. Okay, if this one is tailor-made, then they won't count, this one. So, but if I click here, you see this move down, okay? And then this one moved down to E3 from E2. The next one also moved down more. Okay, so in this case, it doesn't change because the first 3 happen to be in that order. But if it's not, then it will be different. Okay, so that's why I need to put a $sign here. So when I move it down, it will stay there. So like this, see, like now it's stay there, but this one goes down. Okay, so that's the qualitative data that we can use to calculate. And then we'll have, then the relative frequency, you basically just use this number, 2 divided by the total. Okay, and then cumulative, you just add this one, and then this, add this, right? This number, add this, yeah. So that's the relative frequency. And then the bar chart. And do bar chart to display the qualitative data. Like I said, it's not connected, it shows different categories. Okay. So we can do bar chart, like here we have Green Bay, Minnesota, Chicago, Detroit, and how many yards of the, this is the scoring. Okay. So we can do that. And then here is the North Point score. How many points in the whole year they score, okay, compared 2 different years. And then you see like it's not like they are kind of separated from each other. Okay. Then we have the Pareto chart. So it's like a bar chart, but it also show you then you put it in a descending order. So it will, and then they will show you the cumulative frequency. Okay, so whatever category comes in, has the highest frequency, it will be shown on the very left side, and then it goes down. So it will kind of show you like, oh, this happens more often. So happen more often, and you know, so this is the Pareto chart. You have pie chart, you know, just calculate a percentage or to 100%, and then just convert it to the pie chart. So if you talk to a statistician, the professional statistician, they hate pie chart, because pie chart, if you look at this, it doesn't really tells you much. Okay, it will tell you, oh, HP and Dell, they have similar market share, but you can't tell which one is bigger, right? So pie chart actually, but if you have a bar chart, if you have a histogram, they actually show you like which one is taller. But from here, you can't actually see it. But in the presentation, you see a lot of pie chart because it looks nice with different colors. It looks nice. And you can sometimes you can also put in the percentage here in the pie, in the middle of the pie, so that you know it's more presentable. But if you are going to like to present in front of a group of like scientists or statisticians, they hate this because it doesn't really show much, but you know, just look good. So, and then another one is called stem and leaf chart. So they tell us some information. So it will tell us the value of the observation. And then it also show us a frequency distribution, and it will show us which category has the most frequent numbers. So one example is this. So basically this is the exam score, and the stem is you put the point, the 10 or the one above 10 here. So like you have 78, and then 78, and then 379, so 999. And then the next one's 80, 80, 80, 80, 81, 82, 83, you know, so on and so forth, and then 90, 92, 95. So this tells you that it tells you the raw data, you know, not like the bar chart that you didn't know what's in there. You know, okay, we have 5 70s, we have, I don't know how many are these. 16 in 80s, and then 3 in 90s, if we have a bar chart. But you don't know exactly what numbers are there, right? But with this, you kind of have the bar chart here, like you see, like a chart, but if you also see the raw data, okay? So this is good with like a smaller data. If we have hundreds of data, of course, so we don't want to, well, sometimes people do, but we don't want to show this, okay? We have a big group of data. And then we have scatter plot, where you can kind of, you know, put it in and then kind of see the trend. Okay, so this is the scatter plot. So this one, it reminds me We will talk about it next time. I'll show you the example. So tomorrow, Fed is going to announce the interest rate, increase, right? So usually they vote. They will vote for, they will say, okay, 25 points, 50 points, 75 points, 0 point. So you will see like several people vote here, several people vote here. Let me see if I can put it out on the internet. You guys know what I'm talking about? Okay, good. Let me see. Fed interest rate vote chart. Oh, like this. Here. So it's like this, okay? I have people voting here. So this is the 2000, this is one time voting, 2022, and then 2023, they want to move. They think the rate should come here, and then 24, it should go down, and then longer term, here, around here. So this is like their vote, okay? So that's like sort of like a little bit simple one. This. And then the line chart, basically just draw the line, like the very first one we saw here. Okay, the business revenue from 1993 to 2010. So these are the should I put it? The descriptive statistics that we will use. Okay, so you guys, let's try to. You want to do this? Try to do this one, or you want me to just go ahead and do the quiz? You want to do the quiz or either way? Let me just give you the quiz, and you can do the quiz. If you were not here last time, you can go online and then print out the quiz and then submit it. Okay. And then if you are here, you can turn in the quiz here. You don't have to, take photos. Some people took a photo that again is like this way. So I had to, from this way I cannot move it. It's not like on my phone. So I had to like read it like this. Don't do that to me. Don't forget to write down your name. Sure. Yeah. Huh? Oh, here. So you guys want me to, let me turn on the light. You guys can work together, like I mentioned, even for the test or take-home test, but don't copy. You can discuss. You can say, oh, this and that. Don't copy the answer right away, but kind of discuss the answer. Show you. voices that send the tilted answer. So. Yeah,
The last two questions, do you want us to make an Excel spreadsheet to turn that in?
you don't have to, you can, the main point for the last one is to decide how many classes you want to form. And yeah, but you don't have to, yeah, I think you can just do it by hand. So, but you need to, decide how many classes. And then, use the highest value minus the lowest and then group them to different, things. Hello? So, yeah, I think we still have words, but we're going to stop here. And, don't forget to, if you are online, don't forget to submit your answer to the Dropbox. I'm going to put a Dropbox there.
So I can go.
Yeah, you can go if you, but if you can do it now, you should do it now.